What are all the types of matter? Solid, liquid, gases, and plasma are the four types of matter. But the most prominent thing is the first three types of matter: solid, liquid, and gas. Before going to the concept, what is the fundamental blocks of each and every matter? Atom. Atom is the fundamental blocks of each and every matter existing in this universe. Say for example, if you build a home, what is the fundamental building blocks of that home? Bricks. Bricks are considered to be the fundamental building blocks of that particular home. Just like that brick, here atom is considered to be the most fundamental building blocks of each and every matter existing in this universe. So now we came to a conclusion that each and everything is made up of atoms. So based upon this atomic arrangement, how can we classify the three types of matter? First one is solid. Here atoms are very tightly or closely packed. Due to this reason, the solids are very tough, very strong, and very rigid in nature. The next one is the liquid. Here the atoms are slightly loosely packed. The third one is the gas. Here the atoms are very loosely packed. So due to this reason, we can't able to see the gas and we can't able to touch the gas. Now we understood that fundamentals of matter and its atomic arrangements. So now we are going to enter into the core topic, fluids. So we have a question: what is fluids? What is the definition for the fluid? Anything that flows freely is considered to be the fluids. So we knew that liquid state and the gaseous state are considered to be the fluids because both the liquid and gaseous states can flow freely. Say for example, if the mouth of a air-filled balloon is released suddenly, what happens? The air inside the balloon gets exhausted to the outside environment. Here the gas is considered to be the fluid because it flows freely through the mouth of the balloon. And another example, in your home you have an oil container. If unfortunately the oil container fell down, what happens? The oil spills and it flows freely in the floor of your home. Here the oil which spills and which flows through the ground is considered to be the fluid. Now we can able to understood that fluids are either be in the state of liquid or gas which can flow freely. Now there are two major classifications of fluids. One is the Newtonian fluids, another one is a non-Newtonian fluids. The fluid which obeys the Newton's viscous law, then it's considered to be the Newtonian fluids. If a fluid does not obey the Newton's viscous law, then it's considered to be the non-Newtonian fluids. Here the viscosity plays a vital role in the fluids. The basic definition for the viscosity is nothing but of the force between the molecules or between the particles inside the fluids. Say for example, for the viscosity, you know that oil is a viscous liquid, water is a non-viscous liquid. On the basis of these two examples, we can classify that oil comes under the Newtonian fluids, but water comes under the non-Newtonian fluids because the oil obeys the viscous law of Newton, but the water does not obey the viscous law of Newton. Now we see that the example for the liquid state where the oil comes under the Newtonian fluids and the water comes under the non-Newtonian fluids. But what about the gaseous state? How can we classify the gaseous states in terms of fluids? We can classify the gaseous state in terms of fluids into two types. One is a compressible fluids, another one is a incompressible fluids. Compressibility or compress. What is meant by compress? It's nothing but of pressure acting at a particular area is considered to be the compress or compression. Say for example, if you're having a airtight balloon, now you're going to punch at a particular place of the balloon. What happens? The balloon suddenly blasts and the air inside the balloon get exhausted to the outside environment. Here what happens? When you're giving a pressure at a particular place of a balloon, suddenly the air inside the balloon get exhausted. So The air inside the balloon is here considered to be the compressible fluid. The next one is the incompressibility. What is meant by incompressibility or incompressible? It's nothing but of whenever the pressure acting at a particular area, the density of the medium does not change. Say for example you have a U-shaped tube container. Now you are filling water inside the tube. Now on the one side of the tubed container you have a piston. Now you are applying a pressure. What happens? The water level on the another side of the container is gradually increasing. So here what happens? Whenever you are applying pressure at a particular area of the fluid, the pressure transmitted throughout the medium and the changes appears everywhere in the fluid. Due to this reason, there is a gradual increase in the water of the U-shaped tubed container. Based upon this example and based upon this definition for the incompressible fluids, we can state the Pascal's law. So now finally, what is meant by Pascal's law? Pascal's law states that whenever the pressure applied at a particular point of an incompressible fluid, it transmitted throughout the fluid medium and the same changes occurs everywhere.